We are picking up where we left off with logarithms, and we're going to start section 5-6, but I think what you're going to see is that we're going to go at a slower pace than we normally would if we were in class every day seeing each other. This section is all about solving logarithm and exponential equations. And to start off with, we're going to do a little review of the properties that we were looking at last week. First of all, definition of a logarithm. Remember that the logarithm is the inverse of an exponential equation. So y equals log to the base a of x means that x equals a to the y power. The logarithm is equal to the exponent. The base of the logarithm and base of the exponential are the same. And then the properties that we're going to use the most in these problems are these three. The one that says the log of a product is equal to the sum of the logs. The log of a quotient is equal to the difference of the logs. And if the argument is raised to an exponent inside the logarithm, that exponent can come out front and be a factor. We will use these as we solve, usually to condense into a single logarithm. Notice that all of them, the bases have to be the same. We also have change of base formula, which we won't use today, but will be important for some problems in order to put them in the calculator for some of you. There's going to be two types of problems today. We have equations where a log is equal to a log. So both sides of the equations are logarithms, and they have all the same bases. To solve these, you combine each side of the equation to a single log, and then you use the property that says if the log base a of m equals the log base a of n, then m is equal to n. This is like the exponential property we had where it said if a to the m power equals a to the n power, then m equals n. If the logarithms are equal to each other, then the arguments are equal. Again, all with the same base. For example, 2 times log base 5 of x equals log base 5 of 27 minus log base 5 of 3. So here we're going to want to write it so that each side is a single log. So I'm going to bring the 2 in as an exponent. And I apologize for the writing today. I should have better technology by next week to deal with this. So we bring the 2 in as an exponent. And then on this side, we have log base 5. And we want to have log base 5 of 27 minus log base 5 of 3. So we're going to divide 27 divided by 3. And 27 divided by 3 is 9. Put my base of 5 there. And now we're at the point where we have two logs with the same bases that are equal to each other. So we set their arguments equal. And then we solve the same way that we normally would. We're going to take the square root of both sides. I take the square root of x squared. And I'm going to take the positive and negative square root of 9. So I have x equals 3 and x equals negative 3. But with these problems, we may introduce extraneous solutions. So we're going to go back to the original problem and make sure that we go all the way back up here and look at where the variable is in the argument, where it's inside of the log. We need to make sure that whatever is inside of the log is greater than 0. The domain of a logarithm is x is greater than 0. So if I plug in 3, I'm fine. Log base 5 of 3 is good, but log base 5 of negative 3 needs to be excluded. So the only solution is x equals 3. The second type of equation is where we have a log on one side and a number, or we can arrange it so the logs are on one side and a number is on the other side. To solve these, you combine all logs to a single log, and then you have to change to exponential form, and then solve whatever results. So here, I have log base 4 of x plus 3 plus log base 4 of 2 minus x. I need to combine those two. Since they're added, I'm going to multiply their arguments. And now we have a single logarithm equals a number, so we're going to change the exponential form. My base of my logarithm is 4, so 4 to the first power equals x plus 3 times 2 minus x. Now I'm going to multiply out those binomials. First of all, 4 to the first is 4, and I'm going to distribute here. Let me get rid of that. Fix this part. 3 times 2 is 6. 3 times negative x. I'm going to combine my like terms and rearrange here. I have a negative x squared. 2x minus 3x is negative x, and plus 6. And then I'm going to set this equal to 0 from the x squared. I'm going to move everything to the left-hand side so my x squared is positive. So add the x squared, add the x, and then 4 minus 6 is negative 2. This can be factored, and all the problems you have today should be factorable. Factors of negative 2 that add to 1 are 2 and negative 1, and I get two solutions. X equals negative 2, x equals positive 1. But again, you need to go back up to the very top of the problem and check what's inside the arguments. So I have x plus 3 and 2 minus x. If I plug in my answer of negative 2, negative 2 plus 3 is 1, which is okay, and 2 minus negative 2 is 4, which is okay. So negative 2 works. Then I'm going to plug in 1. 1 plus 3 is 4. 2 minus 1 is 1. They're both positive, so they both work. And in this case, we have two solutions that both work in the original problem. Last example, I have two logs that are being subtracted on the left-hand side. So I'm going to combine them. It's log with a base of 1/3. And I'm going to have, remember, the one that's being subtracted goes into the denominator. So I have x squared plus x over x squared minus x. Make this look a little more like a 2. There we go. Equals negative 1. I combine to one log, and then I want to change to exponential form. The base is 1/3, and it's get raised to the negative 1 power. I'm going to put that in parentheses. Equals my x squared plus x over x squared minus x. 1/3 to the negative 1 power. I'm going to take the reciprocal. I get 3 equals. And over on this, I'm going to see if I can simplify. I'm going to factor the numerator and factor the denominator. And I can simplify out and cancel out those x's. So now I have 3 equals x plus 1 over x minus 1. I'm going to multiply both sides by the denominator. And distribute the 3. Over here, the x minus 1's cancel. And now I have a linear equation. I'll subtract x from both sides. 3x minus x is 2x. I'm going to add the 3. 1 plus 3 is 4. And finish solving by dividing by 2. I get x equals 2. And again, I just want to check quickly that when I go back to the original problem, look at each of the original arguments and make sure that the argument will be positive with my answer. 2 squared plus 2, 4 plus 2 is 6. 2 squared minus 2, 4 minus 2 is 2. They're both positive. We're good. So my answer is x equals 2.